This is Mike Biel presenting lab exercise 4, a force transducer with combined loads. In this lab experiment, we're going to take a circular cross-section beam, effectively a tube, and apply axial, torsion, and bending loads to it. Bending loads will be applied in about 2 orthogonal axes. And then there's a total of 10 strain gauges installed on the beam, shown in this pattern here in the gray box. The strain gauges are all applied at the midpoint of the tubular cross-section part of the beam, and the gauges then need to be wired in the appropriate configuration to perform as an axial, a torsion, or a bending transducer. And then for bending, it has to be selected. The right gauges have to be selected for the appropriate axis. On campus at Michigan Tech, this beam is prepared already. However, off-site, as a distance learning student, I did not have this beam, so I made one. First was to identify what gauges I had in stock. I intended to use an aluminum pipe, so I chose -13 STC series gauges. One is a T rosette with 2 active gauges, and the other is just a single gauge grid. I did not have any torsion grids in stock. So first was to start manufacturing this beam. So it's going to have some supports at each end. One support is intended to go into a bench vise. The other end of the support, or the other end of the beam, is going to have some threaded holes in it, and they will allow the attachment of the torsion, axial, and bending loads. Here I'm machining a block that will be used to make the vise end of the beam. Here I'm machining the end of the beam that will have the loads applied to it. So this circular section will fit inside of the tube, and then it will be bonded. Then I'm center drilling through it. There will be a through hole in it that a 1/2-20 piece of threaded rod will go through. This is the vise end of the rod, of the fixture, I should say. And so I'm just starting to machine the circular cross-section onto it that will go inside the tube. All right, here's the finished vise end of it. And I've got a piece of threaded rod that's in a tapped hole. So that threaded rod will be used to apply the axial load. And you can see I also have a set of jam nuts installed, and they can be used to put a tensile axial load on the tube. The tube is not installed yet. This is during the assembly process. I used Loctite 680 to secure the tube to my 2 end pieces. This way I did not have to do any welding and be concerned about heat affecting the material. Loctite 680 is used to adhere drive shafts. So there's about 1/1000th of clearance between the 2 parts. This is the finished test beam. This is the T-rosette that was selected that would be used for the bending and axial load measurements. 350 ohm gauge, and it has a 0.125 grid pattern size. And then this is the single gauge. There's going to be 6 of these used, and two pair of these will be used for torsion measurement. So first is surface preparation. I have to smooth the surface of the tube or the pipe. Next, I need to apply alignment marks. So I'm using a piece of shim stock, a wide piece of shim stock that I can align it on there to get a nice concentric alignment mark. And then I have marks on there to mark angles. After the marks are applied, then I will have to scrub it some more with conditioner A. It was scrubbed with conditioner A before the marks were applied as well. Then I'm ready to bond the gauges. This is one of the T-rosettes after it's been bonded. And here's gauges 1 and 2 that will be used for measuring bending about one of the axes. And then here's gauges 3, 5, 7, and 8. 7 and 8 are for torsion. 3 and 5 are intended for axial or bending. 9 and 10 for torsion. And 6 and 4 for axial or bending. Now the lead wire is being installed. And this is with all the lead wires installed. Everything has been hooked up in a 2-wire configuration because none of these are intended to be run as a quarter bridge. They're all going to be combined to make a full bridge of various combinations. So each gauge has only 2 wires coming from it. The 10 cables were then put inside some electrical conduit, flexible plastic conduit to manage that. And then the ends were numbered. This is the test setup. I'm using a Vichet strain indicator. And so I'm connecting, depending on what load I'm measuring, I'm connecting a certain set of gauges in a full bridge configuration. I'm using a 24-inch moment arm for the torque load, and then there's a spherical rod end to hang the weights from. Now there's a hanger installed and there's a weight on there, so I have a torque applied. This is with 3 combined loads. There's a torsion load, there's a bending load hanging from the center of the beam, and then if you look closely you can see the nut is tight and it is applying a compressive axial load to the pipe. And the beam can be turned 90 degrees to provide bending about 2 different axes. So a set of axial load measurements were performed by connecting the appropriate gauges together in a full bridge configuration. Then a different set of gauges were connected in a full bridge to measure torsion. And then last, bending load was measured about two different axes, the Y prime and Z prime axes. And then load sensitivity was investigated to see if other loads besides the intended load would contaminate the desired measurement.